Hi everyone, I'm John, I'm a developer. Yeah, I've been writing code for quite a long time. That was my first computer. That's a ZX81. The clue for the year is in the number. So yeah, I've been doing this quite a long time. So I'm going to be talking about microservices. That's a very technical subject. I know that's maybe not going to mean a lot to a lot of people, so I'll try and not use lots of nasty words. So we'll see how it goes. So the problem that I'm looking to solve is about helping people be able to engage with the community more easily, especially if you're a developer. So, Stefan here is a developer. He'd love to contribute to Open Food Facts. He's got some ideas about organic foods that he'd really like to implement. So he comes and has a look, and this is what he's faced with. This is the opening page of GitHub in Product Opener, and he's got to learn Perl, and there's Mongo, and there's NPM, and there's so many different technologies, and it does everything. So he's had to learn all these different domains, and it's quite scary, and he's a bit intimidated. So the idea of microservices, it's a very old concept, and it's to do one thing and do it really well. And so the idea is that you split the system up so that you focus on doing individual things. Now, the way people would traditionally split a system up is they do like front-end, back-end, database, mobile. But the problem with that approach is that people working at each level still need to know the whole system. And that's very difficult because they might be interested in a particular area. So the microservice approach basically says, let's just break the system up and do the whole thing for each individual domain. So ingredients analysis, Nutri-Score, and this allows us to focus on what interests us and maybe use the right technology for the job. So if we're using, for the product database, that needs to be very open. If we were doing a user preference database, that needs to be very secure. If we're doing a database that's recording every single scan someone does, well, that's an append database. It's very different. So we don't have to use the same technology to do everything, but we can keep it encapsulated so that it doesn't become huge and scary. So hopefully what happens now is Stefan comes along and then Alex says, we could do with some help in this area or this area. And now each of these things only has a small number of technologies involved. So it's not so overwhelming. They don't have to learn the whole domain. They can focus on one particular area. So Stefan says, yeah, that's great. I'm really interested in machine learning. I'm going to look at how the logo recognition works or something like that. And he can work on that without being too scared. There are risks with this kind of model when you split things up. So this is called a sequence diagram. So if you've got separate systems doing all these different things, you link them up, someone creates a new product, and now it's got to go to the OCR service to scan the, sorry, I shouldn't say acronyms, but that's where you scan, turn the picture into text. It's got to do that, and then it goes to the ingredients parser, and it has to do that, and then it can calculate the Nutri-Score, and it can be a lot of backwards and forwards, and if one of the systems breaks, the whole thing falls over. So it creates multiple points of failure. So the way you get around that is using an event-based model. So what then happens is that rather than wait for all of these things to happen, when you add a product, it puts it on an event bus and says, hey, there's a new product. And the image scanning says, oh, that's interesting. I'll create the ingredients list. And then it says, there's some ingredients lists. And now the Nutri-Score can say, I'll calculate the Nutri-Score. And it can say there's a Nutri-Score. And so but it does have an impact on the way you use the product, because now you're not getting instant results. You submit the product, but we don't know all the information straight away. So you would typically have, I'm waiting for these things to come through, and then it eventually fills in. And there are ways of doing that. With different browser techniques, there are ways you can do that. And then, in this case now, if one thing goes wrong, well, okay, I'm not seeing my Nutri-Score at the moment because the ingredients analysis is maybe broken. But because the event is still in the system, when the ingredients analysis is fixed and comes back up again, it can catch up and finish processing all the products that it hasn't processed yet. So it recovers. So there are a number of ways of doing this. There's techniques called domain-driven design, where you break the system up into the domains. There's some techniques I would like to try tomorrow called event storming, which I'd like to look at for ingredients taxonomies. Something you can do, they encourage you to do, is to look at that domain in its entirety. So again, rather than treat something like taxonomies as a very general thing, is to say, actually, I'm going to focus on ingredients. And ingredients would own the ingredients taxonomy, and categorization would own the categories taxonomy, rather than have these general things. So it means that when you have a smaller domain, people get more focused on that domain and refine that domain much more than if they're working on something very general. So you get a better feel. There's a fear about duplication, and there's always a compromise there between duplicating stuff or making stuff easy to get hold of. But one of the things I think people often overlook is that a microservice approach is really about people. It's about organizing your projects around the people and what works best. And so there's not one size fits all. That's something we need to talk about, is what's going to work best. But it's to create a technical environment that supports the community, structured in a way that works best for that community. You do have to standardize a few things. I often say this to other people. There's a balance between autonomy and anarchy, and you don't want to go too far because it can be chaos, and there is only a small permanent team who have to keep this stuff up and running. So we've got 100 different services all doing different things. That could get very scary from a maintenance perspective. So there's lots of things you can standardize on. Maybe only have one type of database for certain types of things. Standardized logging, standardized metrics, those sorts of things, just to make it a little bit easier to manage. The good news is there's lots of stuff that's actually already done. This is not really that new to Open Food Facts. I'm just kind of suggesting we do it a bit more. It's mainly a technical thing. It's to improve the developer experience. I give an example, as Stefan mentioned, I work 1 day a week on Open Food Facts. Product Opener takes about 40 minutes to do all the tests. So when I make a change, I've got to wait 40 minutes to make sure I haven't broken something. Now, when you're only working 1 day a week, that's a long time. So by splitting things up, I can get faster turnaround. That makes me happier. That maybe gets more developers engaged. And that's where it may be interesting to other people who aren't technical, because if more people get engaged, you get your stuff quicker, and you possibly get more contributors because they're less scared and they don't look at the Perl code base and go run away, because it's a little bit more friendly. So yeah, I think that's all I wanted to cover. So I don't know if that was 7 minutes. Thank you.